Alright, so let's go through these hydraulic press questions. So the figure shows a simple hydraulic jack. Okay, so the objective for using a hydraulic jack is actually to use the minimal force to lift a very heavy object. So normally for the force, right, we call it effort. The effort you actually apply on the left hand side of the hydraulic jack, the right hand side you place the object. So you apply the force, right? So for example, let's just say, oh, my force is normally for example 2 Newton. I can actually lift up an object of maybe weight to be 10 Newton. So that is the objective of your hydraulic jack. Okay, so they say what change will actually result in the heaviest load being lifted right at the handle. So of course I just draw a very simplified diagram lah. So this is a very simplified diagram. Okay, so first we must understand that P1 is equal to P2. The pressure is the same at both sides due to the fact that there's a Pascal principle. Because the liquid in the hydraulic jack is incompressible, so means that the pressure is being transmitted uniformly from the left hand side to the right hand side. Okay, so we know P1 is equal to P2. Okay, so the next part we need to go back to the fundamental equation. So we know that pressure is equal to force over area. So F1, right? So what is F1? F1 is the effort that I press. Then what is A1? A1 is the area of piston W is equal to F2. F2 is the force that can lift up the object, right? A2 is the area of piston Z. Okay, so next I rearrange the equation such that I make F1 the subject, meaning F1 is equal to A1 over A2 F2. So I want to leave as the F2 to be as big as possible, right? Means that this A1 over A2, right, must be as small as possible. So I can actually use the minimal force to lift the heavy object. Okay, so A1 is the left hand side, right? The area of the piston on the left hand side. A2 is the area of the piston on the right hand side, meaning piston Z. Okay, so looking at the option, definitely because we are not given area, but we are given diameter of W and diameter of Z, but they are like directly proportional. So means I can just simply choose A, because A, W, right, the diameter is half. Then for Z, right, the diameter is doubled. So you do the calculation and you realize that this option A will give you the smallest A1 over A2. So that is how we actually do this question.